to Game Day with America Makes at Rapid Plus TCT 2023. I'm Laura Griffiths, Head of Content at the TCT Group, and I'm joined by two very exciting people today from PepsiCo. Very excited to talk to them today about all the ways PepsiCo is using additive manufacturing. First of all, guys, just please introduce yourself and what you do at PepsiCo.
So my name is Thangthip. I'm part of Pepsi Global Beverage Packaging R&D. I'm currently a senior engineer within the Advanced Engineering and Design team, currently leading our Advanced Rapid Prototyping pillar. So really looking at new and emerging technologies within additive manufacturing and how we can leverage that to fast track our package development process. Pass it on to Max.
Hi, hello everybody. My name is Max Rodriguez, and I lead the Advanced Engineering and Design team for Beverages Packaging R&D at PepsiCo. Been with PepsiCo for the past 10 years, and yes, what we do is look at advanced capabilities to fast track our packaging development process.
And you've got a really interesting story that you're presenting today at the Rapid Plus TCT conference, all about really just accelerating this product development time. But I really want to understand first, how did you go about the application discovery with 3D printing inside your organization?
Yep. I'll take that one. Yeah, so for us, additive manufacturing is an enabler to fast track packaging automation. And our traditional process of making our prototypes and making our first production samples normally used to take around 4 to 6 weeks. And what we really needed was a technology breakthrough that would allow us to fast track that development process. And additive manufacturing has turned out to be a great enabler. What it has allowed us to do is to go from that 4 to 6 week process to within 48 hours, which is a significant breakthrough for us. But it's coupled with more advanced capabilities that we've also developed, such as virtual analysis, finite element analysis, virtual tools, that allows us to first be able to prototype in a virtual environment, look at how do we iterate and optimize the design, and then utilize additive manufacturing to validate that optimized design in a physical environment. And that's really what is the whole ecosystem of the tools that we've developed that has really been a breakthrough for our company in being able to truly accelerate our packaging development process.
And it's quite a unique process that you're using in-house. What made you decide to use this particular type of hybrid technology?
All right, want to take that one?
Yeah, so for our application, it's focused in on stretch blow molding. So we needed a material that had a high HDT, high heat deflection temperature, and would be able to withstand the pressures that we would experience in stretch blow molding. So, with new material companies, developing those types of materials like the PEEK resin from Henkel, we've been able to, work with that with our patented modular mold set technology, and using a unique way of backfilling it with a dental material. So that combined, the combination of subtractive manufacturing to machine our mold carrier alongside with 3D printing the inserts with the PEEK resin and then backfilling it with the dental material, we're able to create these functional samples that are very much modular in nature, ranging in different sizes, while still being able to meet the properties that is required to successfully blow these samples internally.
And I think with additive manufacturing, particularly as the industry matures, there's a temptation to go straight after those end-use, customer-facing applications, but this is very much about the manufacturing process and really accelerating that. Can you talk about maybe the importance of additive in those sort of behind-the-scenes applications and finding applications like this?
Yeah, so for us, really, the use of additive manufacturing is what you would know as traditional applications in prototyping. So we do low fidelity prototypes using additive manufacturing. We use, at the beginning, we'll use non-functional prototypes, your typical FDM style printing technology. And then we graduate into a more high fidelity, non-functional prototypes, the ones that actually look very real and is comparable in aesthetics to what you would see out on the shelf. And then we graduate to the more advanced capabilities that our patented breakthrough technology that actually are able to do fully functional prototypes. But we have a lot more higher aspirations than that. We do want to get into being able to not only do prototypes for development, but also eventually be able to put our mold tooling technology into a production environment. So we are looking at developing technologies in metal additive manufacturing, for example, that will not only take us from the 10,000, 20,000 samples, but into the millions. And that's really the breakthrough evolution that we're developing for PepsiCo, is the capability to go from a CAD file to a million bottles out in the marketplace at a record pace, at a record time, without compromising the quality and the aesthetics of our traditional production quality packaging.
There's some really huge ambitions there. So talk to me more specifically about the presentation that you guys have got later on today and the success story that you've had, because there's some really impressive numbers in terms of lead times and just reducing costs. Can you talk to me about that in more detail?
Sure, go ahead.
Yeah, so for today's presentation, we're really going to be showcasing, some of the capabilities that we utilize within Pepsi and how that really helps accelerate our package development process. So, we see additive as a complementary, technology to the existing conventional technologies out there, right? We don't see it as, either competition or replacing one or the other. As you see with our mold set, right? It's a combination of both. We're really leveraging the benefits of both technology, and that's what's really been able to help fast track that lead time. To go from 4+ weeks externally for a tool to within 2 days internally. So it's really, leveraging a combination of technologies, not just like from manufacturing, but also the virtual tools to do the analysis early on and then move forward into physical, right? So it's really interlacing, a variety of different technologies, techniques that really helps us, get to that speed that we're able to achieve now.
And I'm also interested, when you talk about some of the ambitions you've got for the kind of volumes you were talking about just a moment ago, what kind of challenges do you see in the additive manufacturing industry at the minute? What kind of things are missing in order to get us to those types of volumes and those types of applications in the future?
So additive manufacturing has evolved so rapidly, and it really is facilitating it, being able to do this at a record pace. We started this journey about 7 years ago with the technologies that were out of our price range. Your very high-end printers in the 6 figures, and now you have the same quality of printing at a significantly reduced cost. What we're focusing on, though, is making sure that we have a high print resolution, the high level of fidelity, and being able to utilize more advanced engineering materials that are able to withstand the processing conditions that our applications are going to put it through. We stretch blow mold our bottles with high pressure air in the 40 bar range. We also reheat our preforms at elevated temperatures, and there's going to be a heat load in the material. So we're looking at materials that are able to withstand those applications. On the injection mold side, obviously when we injection mold our polyolefin components, we have very elevated temperatures as well. And that's where I think additive manufacturing has come a long way. It's in really developing this vast variety of materials, and also combined with the technologies that are constantly improving in terms of driving higher resolution, higher fidelity in the 3D printing technologies. So I think it's there already for us to be able to exploit it. It's just up to us to be able to put everything together and develop that case study and proof of concept that will take us on to the next step.
Yeah, for us, we definitely start with the application in mind, right? We have an application identified. Now it's a matter of finding the right technology for our, for the end use product. In terms of honing in on your process, your parameters, your print parameters, or surface finish, etc., things like that. Those are kind of, work that is relevant to any type of manufacturing process, right? So it's the ability to you know, have the application in mind, and then going out there and finding the right technology for it, and then, you know, the rest is part of the workflow of honing in on your, you know, on your process.
Well, I hope you're in the right place to find it this week at Rapid Plus TCT 2023. Thank you both so much for taking the time to speak to me today. I really appreciate it. And you can catch these guys later on at the Rapid Plus TCT conference too. Thanks very much.
Thanks for having us.
Thank you.